Okay, so this video is going to help you with section 6.2, the definite integral and net change of a function. So in 6.1, we talked about anti-differentiation, which is taking integrals, undoing a derivative. Now we're going to be talking about taking integrals, continuing to take integrals, but now we're going to talk about definite integrals, whereas last class we were talking about indefinite integrals. A definite integral basically looks like this, where you're taking the integral from one point to another point, from A to B. Basically, it's a more practical use for integration. Like, for example, if you're given the velocity, a velocity function of an object moving along a straight line, and you're asked to compute how far the object has moved, then you need a starting point and an ending point, and that's what this A and B represent. Definite integrals are really easy to take. It's just like what we were doing last class. But once you take the integral, you plug in B and then plug in A into your final function and subtract the two. And that will you'll actually get a numerical answer when you take a definite integral. You won't just get a function like when you took an indefinite integral. Okay, so I'll show you. I'll work a couple of integral problems. So for example, if you're asked to compute the definite integral of x dx from 1 to 2, it's pretty straightforward. We're just going to first find the integral of x dx, which again, using your rules of integration, we're going to see that that's going to be 1/2 x squared is going to be the integral of x. And so now we need to find we need to plug in f of 2, which is going to be 1/2 times 2 squared, which is going to be 4 over 2, which is 2. And then we're going to find f of 1, 1/2 times 1 squared, which is going to be 1/2. So we're going to say f of 2 minus f of 1, which is going to be 2 minus 1/2, which is 1/2, or 3/2. So 3/2 is the integral of x dx from 1 to 2. Pretty straightforward. Okay, so if you're asked to find the definite integral from 2 to 6 of 5x to the negative 1 dx, again, we're going to pull out your rules of integration sheet. And first we see we can pull this 5 out. So this can be 5 times the integral of x to the negative 1, which is the same thing as saying 5 times the integral of 1 over x dx. And if you look at your integration sheet, you see the integral of 1 over x is natural log absolute value of x. So this is going to be 5 times the natural log of the absolute value of x. So now we need to find, we're going to plug 6 in and 2 in. So we're going to say f of 6 is going to be 5 natural log 6. F of 2 is going to be 5 natural log 2. And so the definite integral is going to have to be 5 natural log 6 minus 5 natural log 2. You could factor a 5 out here, I guess. And that would be the definite integral of a problem like that. Now if we're given an integral that looks a little bit, there's a little bit more to this one. Again, it's still pretty straightforward. The first thing I would do here is, do you see how this is the same thing as saying the integral of 1/7 e to the x plus e to the negative x? Now we can factor the 1/7 out of the integral, and we've just got the integral of e to the x plus e to the negative x. So to integrate this, we're going to say 1/7 times the integral of e to the x is just e to the x. So it should be parentheses like that. And then the integral of e to the negative x is going to be negative e to the negative x. So that is the integral, now we just need to plug in natural log 6. So f of natural log 6 is going to be 1/7 e to the natural log 6 minus e to the negative natural log 6. So that's going to be 1/7 times, remember when you have e raised to a power of a log with the same base, and remember natural log is log base e, these match, so your answer is just what you're taking the natural log of, so this is going to be 6 minus, we have to look at this as, since there's a negative exponent here, we have to look at this as 1 over e to the natural log 6. So we can simplify this to be 1/7 times 6 minus 1 over 6. And then if we find f of 0, that is going to be 1/7 times e to the 0, anything raised to the 0 is 1, minus, again, 1, which is 0, it's just going to be 0. So when we say f of natural log 6 minus f of 0, we're going to get 1/7 times 6 minus 1/6, that's going to be 36 over 6 minus 1 over 6, which is 35 over 6 times 1/7. Then you can cancel the 7 and the 35, so we end up with 5 over 6. So that problem is a little bit more to it, but it's more the algebra than the calculus that gets complicated. And then the last thing that we're going to talk about in this video is the properties of the definite integral. A lot of these properties are really intuitive, very similar to properties of differentiation. If you have an integral of two functions, you can split it up and take the integral of two functions separately. The main thing that you want to see is this property. Basically, if you have an integral from a to c added to an integral from c to b, you can add those two integrals together to get an integral from a to b. And it's demonstrated a little bit better, I think, when you actually work through a problem. So for example, if you're given an integral here from 0 to 6, the integral from 0 to 6 of f of x is 8. And then the integral from 5 to 6 of f of x is 7. What I do is I just go ahead and draw this on a number line. We've got 0, we've got 5, and we've got 6. Those are all the points on of the integral. We know the integral from 0 to 6 is going to be 8. So from 0 to 6, we have 8. And we know the integral from 5 to 6 is 7. So what would logic tell us that the integral from 0 to 5 would have to be? Do you see that the integral from 0 to 5 would have to be 1? Because if the integral from 0 to 6 is 8 and the integral from 0 to 5 to 6 is 7, do you see my scale is way off here? But 8 minus 7 would give us 1. So that's all those problems. You'll have a couple of problems in the homework, and that's all you really have to do. You just want to draw it out on a number line, and even if the scale is off, you can still come up with the answer if you use your algebra.